So see, if I give you a glimpse again of the atomic size, then what is atomic size? Very, very simple thing, that if we will move down the group, then the shells will increase, and if the shells will increase, the size will also increase. And if I move left to right in a period, then what will happen? Then the nuclear charge will increase, and hence the size will get reduced and reduced, right? Now what are we going to study? Now we are going to study about the metallic character. See what happens to the metallic character. Before understanding this thing, then what happens to the metallic character, first let's see that which atom will show the metallic character, which will not show the metallic character. So if I talk about the metallic character, can you tell me that the metals like to give the electron or they like to take the electrons? For example, can you give me one example of the metal? Yes, it could be any element of the group 1, right? For example, sodium. Okay. Now the sodium like to lose the electron, right? They just want to convert into Na plus. Why so? Because what is the atomic number of sodium? It is 11, right? It means the ratio is 2, 8, 1. Technically not the ratio, but yeah, it's first shell there are 2 electron, second there are 8, and outermost me there is only 1 electron. So the sodium will just try to get rid of this 1 electron to attain a noble gas configuration, right? So we see that they like to give the electron. Sodium likes to give the electron. In which group the sodium is? Sodium is in group 1. Sodium is in group 1. Alright, all the element of the group 1, either you talk about potassium, rubidium, lithium, hydrogen have a little different character, but still if you talk about the group 1, right, you will see that all of them want to lose the electron, and after losing the electron they attain a stable configuration. So okay, then let's come to the group 2. What is happening in the group 2? There is beryllium, there is magnesium, and we see that these are also eagerly waiting to give the electron, right? Magnesium also give its 2 electron and turn into Mg plus 2, right? So they are also considered as metal. But how will we know this thing, that which element or which group's element are more metallic, which group's elements are less metallic? How will we know this thing? See, first of all we have to see that what do we actually need. Agar if I want to donate an electron, so what should I have for that? The thing which I should have is, first of all, the thing which will help me is large size. First thing which will help me is large size. Second thing which will help me is the lesser nuclear charge. Lesser nuclear charge. No need to write right now, just understand everything. I will be writing everything and then you can note it down, right? For now, right now, don't write anything. Okay, see, now how large size will help? See, in the previous class we have studied this thing, ki agar if I have a nucleus over here, right? And let's consider an example of sodium and let's consider an example of potassium. Both of them gives the electron and both of them are from the group 1 itself, right? But if I talk about sodium, what is the atomic number for sodium? It's 11. So what is happening is, see, first what is happening is that if I have 2 electron innermost, 8 and 1, and what will be the scenario in the case of 19? 2, 8, 8, 1, right? Acha, okay. Now if I'm writing, okay, the electron numbers are increasing, with the electron number proton number are also increasing, yes, absolutely. But if I talk about this case, in this case, this is my like we could say this is my nucleus with the positive 11 charge. Then in the first shell there are obviously only 2 electron. In the next one there are 8 electron, and in the next one to it there is only 1 electron. And while if I talk about potassium, what is happening? There is a charge of 19 proton in the nucleus. Then first shell which is having 2 electron, second one which is having 8 electron, next one which is having 8 electron, and the next one to it which is having 1 electron, right? Okay, so I could write over here 2 electron, 8 electron, 8 electron and 1 electron. Now you will see this thing, in this case also the nuclear charge is increasing, right? Whether this nuclear charge is lesser than that of the 19, but still the potassium can give the electron easily. Why? Because one thing I just like said in the previous class, that was shielding effect, but today I will tell you what the shielding effect is. Shielding effect is that these inner shells, right, these inner orbits, for example the orbit of 2 electron, the orbit of 8 electrons, these just protect the outermost electron. How will it work? This will only work that all the attractive force which this proton have, right, which these protons have, is being, we could say, is being like shielded out, right? Like it has been occupied by all these electrons, and the outermost electron face the least attractive force, right? Okay, first thing, that there is a shielding effect, other electrons are protecting the outermost electron, something like that, right? Okay, and the second thing, what is happening, that this electron is more far away from that of the nuclear charge, and more far the nuclear charge is from the electron, lesser the attractive force is on the electron. So in this case the attractive force is more on the electron, in this case it's less. So what if the attractive force is more, ma'am? If the attractive force is more, this nuclear charge is holding that electron, it will not let it go, there is an attractive force. While in this case, when the nuclear charge is the more itself but the distance is high, so attractive force is less on the electron and the electron will move easily out. So this is what is happening. And similarly, if you will move from potassium to rubidium, what will happen? The radius will increase more, hence attractive force will reduce more, shielding effect will increase, and then the electron will move easily. So what is happening because of the large size? We can say larger, abhi bhi you don't have to write, I'll tell you when you have to write. Larger the size, what is happening? Larger the size, less is the electronic attraction, or we could say electrostatic force of attraction on electron, that is also what we can write. And because of that, what is happening? Electron lose easily, right? This is what a summary, I will write it in detail and then you copy that. Okay, you can write lesser is the electrostatic force of attraction on electron. Acha, theek hai. Now what about this nuclear charge? What will happen if there is a less nuclear charge? Let's see. This was the case when I was moving top to bottom in a group, and I see that when I'm moving top to bottom in a group, my metallic character should increase. Why? Because size is increasing, right? If I move top to bottom in the group, the size increases, and if the size increases, what happens? Then larger the size, lesser is the force of attraction on the electron, and they lose the electron easily. So moving top to bottom in the group, size increases, and hence we could say the metallic character also increases. The metallic character increases, right? Matlab, totally the metallic character, how are we looking at the metallic character of an element? Just by seeing this thing, that either it is able to donate the electron fast, easily, it's taking more energy, whatever. So everything we are assuming on the basis of the donation of the electron only when it comes to the metallic character, right? Acha, now let's see the lesser the electronic nuclear charge also. If I am moving from, let's say, from lithium to beryllium and then to boron as well, right? How many electrons are there in it? 3 in it, 4, and in it 5. Technically you can see I'm moving from left to right in a period. So what will happen in this case? In this case there will be positive charge of 3 plus, then 2 electron in the innermost and 1 electron in the outermost. Then let's talk about this beryllium. Then there are 4 positive proton, then 2 electrons, and then again 2 electrons, right? Then let's talk about boron. There are 5 positive protons, and then 2 electron, and then 3 electron in the outermost, right? Okay. Now if you know the first trend we have studied, that is of the atomic radius and indeed atomic size, we know this thing that if we are moving from left to right in a period, then the size decreases. What was the reason of the size decreasing? The reason of the size decreasing was this increase in the proton charge. Now, first of all, you need to see that if I talk about the first orbit itself, the first orbit in all of these three cases, which is having 3 electrons or 2 electrons only. So in the first case, on these 2 electrons, only positive 3 plus is acting. In the second case, on these 2 electrons, 4 plus, that is positive charge of 4, is acting on these 2 electrons. In the next case, what is happening? 5 positive electron charge is acting. And because of that, what happens? The attractive force is more in the case of 5 protons, and then the size reduces. What? Because of that? Because of that, you see that the attractive force on these electrons, the outermost one, also increases. Why? Because the size is reducing. It means those electrons are coming closer to the nucleus. If they are coming closer to the nucleus, what is happening? The attractive force on them is increasing more and more. And as you will move from boron to fluorine as well, like more right to the group a period, then you will find this thing that this attractive force is increasing more. Hence we see that because of this attractive force is increasing on the outermost electron, the nuclear charge, right, that is the proton charge, is attracting the electron more, or we could say holding the electron more, and it is not letting them go out, right? While in this case, the attractive force on this is lesser. Why? Because you see there is only plus 3 charge, while in this case there is a plus 4 charge, which is more than plus 3, and hence there is a greater attractive force on these electron in comparison to that of this one, right? And hence it is increasing more in the third case, right? And so on, it will keep increasing. If you will take the case of carbon, where there are 4 electrons in the outermost and positive charge of 6 in the nucleus, over there the attractive force will increase more. And what will happen because of that? The electron will be binded more, like with the more strength, and hence it will not be easier for them to lose. If the what is happening, that if you are moving from left to right, what is happening if you are moving left to right in a period? The size is reducing. Why is the size reducing? Because of the more attraction on outermost electron and the innermost also, or you could directly write that more attraction on electron. And what is happening because of more attraction on the electron? It is not easy, right? Not easy to lose electron. And what if it's not easy to lose the electron? The metallic character reduces, right? Metallic character reduces. And if the metallic character reduces, what do we say? That they are not the good metals. So we have studied two things. What are those two things? That if I am moving top to bottom in a group, then size increases, and hence the metallic character also increases. While if I am moving from left to right in a period, then what happens? The size reduces, the nuclear charge on the electron increases, it's not easy to lose the electron, and hence the metallic character reduces. Simple thing, top to bottom, metallic character increases. Left to right, metallic character decreases. Simple thing, right? Now I'll write it and then you copy what I'm writing. So you can take a snip of this, right? And now I'm scrolling it as well. The nuclear charge, like it was just the character on which, the metallic character of the element on which it depends. So first was the atomic size and the nuclear charge. Then there are the trends in the metallic character. Down the group, metallic nature increases as one moves down the group, and this is what the example could be. And across a period, what happens? The metallic character decreases, right? There is an example also for the period 1. Now we will move to the non-metallic character.